Hi, I'm Dave Neary, and for this episode of Ampere Developer Impact, I'm joined today by Victor Jakubiuk of Ampere Computing and Ricardo Rocha from CERN. Nice to have you.
Well, glad to be here.
Thank you for having us, Dave.
So you were both on a keynote panel this morning to talk about sustainable AI inference at KubeCon Europe, which is where we are in Paris, beautiful city.
Yep.
And I was really interested by the different perspectives that all of the panelists had. Can you talk a little bit, Ricardo, about how you see the future of AI inference and how we can make that more sustainable from the perspective of CERN's use cases?
Yeah, so what we're talking about today, and from our perspective, one thing that we can really improve in terms of sustainable AI is to improve the overall utilization of the resources we have. So I mentioned a couple of things that we've been looking at and that try to tackle these problems we have with spiky workloads that can be kind of bursty and not very predictable for things like inference or interactive analysis that we do internally. In those cases, we would like to be able to share resources better. We see a pretty low overall utilization for these kind of workloads. So we've been trying over the last couple of years to investigate how we can do sharing and time slicing better, or even physical partitioning of accelerators like GPUs. Okay. And on the other side, the batch workloads, which are more long-running, more predictable, but where we also want to make sure that we can always fill up the farms we have. And this means adding to things like Kubernetes and cloud-native tools, the primitives we are used to from HPC centers and queuing, priorities, all this kind of thing.
So you mentioned that the utilization of these resources is low. How much? Like what percentage of your GPU resources are utilized?
Yeah, so this is really depending on the use case. But for the batch workloads, we know we can get pretty high on the 80s, 90%. For the interactive workloads, because they are not predictable, people tend to overcommit their requirements, and we end up seeing things like 20, 30% utilization. And this is where the motivation to put more workloads that can easily be co-located in a single resource, this is where things come from.
Okay.
Yep.
So, Victor, you brought a different perspective to this conversation. In terms of, can we use general purpose CPU for inference workloads as a way to avoid the power usage and the cost of running on GPUs? Can you talk a little bit about that?
Yeah, absolutely. So I focus on efficient AI inference and specifically GPU-free AI inference. Turns out that you can run AI inference, not necessarily training. GPUs are very good for training, but AI inference you can run very efficiently on general purpose CPUs. And there are multiple reasons for that. And the workloads you can run are anywhere from your traditional ML to the latest and greatest LLMs like Llama 2, for example. And you can run them very efficiently on general purpose CPUs. They tend to be easier to scale than GPUs, right? And you can kind of co-locate more of those workloads, not just AI workloads, but also your general purpose workloads like your GPU, like your web server, your database. You can run all of them on the same box.
Okay. And is that limited by the model size? For example, something like a domain-specific chatbot would be a good match for that, but general purpose LLM might require more compute than you can get off a general purpose CPU?
Well, you can run all sorts of LLM models, all the way from small models to large models. I think the sweet spot for AI inference on CPUs is for models probably like up to 10 or 20 billion parameters.
Okay, and Ricardo, you also mentioned that when we were talking before, you talked about CERN looking at ARM64 generic CPUs as a way to reduce power usage in the data center. Can you talk a little bit about that?
Yeah, so basically internally we have we tried every sort of technology that can help us do better with the same. Basically, right. That's our goal. So there are some requests to have access to ARM processors, and we have some integration with our CI processes. So what the actual usage of this kind of resource will be, it's still to be decided. I think all these things are moving pretty fast. One thing that we also see is, for example, for the GPU requests we get, the trend on the GPUs is to actually make them larger and more larger amounts of memory and more capability. For some of our workloads, this might not be the ideal thing. We have some workloads where the models are pretty small, so we really need to get the picture better of fitting the workloads to the good resources or making better use of these very large resources that sometimes are underutilized.
So when you're looking at where you can deploy ARM64, you're looking at both AI inference for smaller models and general purpose CPU, is that what you're saying?
I think for now it's mostly general purpose, but we will keep looking at more and more alternatives for this all our types of workloads. Yeah.
And Victor, I know we've talked about this before. We call Ampere processors cloud native CPUs. Can you talk a little bit about what that means? Like what makes it a cloud native CPU? After all, we are here at the Cloud Native Computing Foundation event.
Yeah, so there are a couple of reasons, a couple things that go into being cloud native. For one thing, you need to be able to run all the cloud native software, for example, like Kubernetes. So all of that runs well on CPUs, and it's generally much easier to orchestrate than having to use GPUs. So that's first thing. Second thing is, well, if you look at some compute-intensive workloads, like for example AI inference, you want to ensure that there are no, for example, noisy neighbor problems. If you're running your AI inference on a 30-core VM, you don't want your database workload running on the other 60 cores VM to slow down just because you're running inference on the same machine, right? So that's what cloud native means. A cloud native CPU can run the same workload at the same performance, regardless of what your neighbors are doing on the machine.
Okay, and can I get into a little bit of specifics about the workloads? You've talked about things being workload specific. Yeah. So what kind of models are being run in CERN, and what do you see as the resource demands for those different types?
Yeah, so it's been kind of scaling up on this kind of requests. We started by doing a lot of machine learning for beta simulation, things we call it fast simulation, and replacement for traditional Monte Carlo simulation techniques using things like 3D GANs and similar models. And then, of course, with the trend for LLMs, transformers are becoming more and more popular, to the point where we actually realized that a lot of the workloads we traditionally had with custom electronics that we built in our detectors, now we have the possibility of replacing a lot of this specialized hardware with more commodity, easily accessible hardware, whatever it might be, to do things like inference with very low latency requirements. So these are things that we are learning now how to use. There we have a few projects internally that are looking at this kind of thing. Okay. I think the next couple of years will be pretty exciting.
One of the things that you talked about in the keynote today, or one of the things that was discussed in the keynote, was the ability to do GPU-less AI inference on Oracle A1 instances. Can you talk a little bit about how people can avail of that, and why would they use A1 for inference today?
Yeah, so A1 instances are available on OCI today. The entire AI software stack, whatever you may want to use, whether it's TensorFlow, PyTorch, Llama CPP, all of that runs out of the box. So all you have to do is just spin up a VM and give it a try. There are AI-focused or AI-optimized VMs on Oracle's marketplace, if you would like to start there, that come preloaded with quick examples, with demos, with all the best practices. So if you want to run a GPU-free AI inference, it's already available today. You can just go there, give it a try. You don't have to follow the marketing of GPU companies that you can only run AI inference on GPUs. It's super easy to run on CPUs, and it's also very efficient. It's very price performant, very efficient for AI work.
And Ricardo, from your perspective, what's your next step? Like how are you going to improve the efficiency of GPU utilization, or use general purpose CPUs instead of GPUs where you can? Yeah. To get to a more efficient.
So I think for us, we've been quite involved in the community, on the cloud native community and Kubernetes. There's a lot of work going around what's called DRA for a more dynamic way of defining resources and resource needs from the workloads.
Yeah. I think DRA stands for.
I think it's dynamic resource allocation, and this is what we think will help us have a more a generic way to say what the workloads actually need in terms of resources. Traditionally, we had CPU, memory, not much more. All the rest is kind of proprietary to the different drivers and resource drivers that are included. So having a more generic way of defining this in the same way we do storage. We say, I want fast storage and I want slow storage, but it's up to the user to define what fast and slow means. Having this sort of abstraction will be quite important for us, and it will make us be able to be more flexible in what type of resources we actually use in the back end, depending where the workloads land. Yeah.
So basically, matching the use case to the right hardware rather than forcing a certain utilization.
Yeah, exactly, and even be flexible on even with the same description of what the resource requirements are. Depending where we are running, we might end up choosing different types of hardware depending on the availability. So these are the things we think the community is pushing for, and I think this will help us a lot as well. Yeah.
And it's exciting times. I mean, AI is all over this event, all day today.
Yeah.
And so thank you both for joining me.
Thank you, Dave.
Victor and Ricardo.
Thank you.
And I look forward to seeing you all on a future episode of Ampere Developer Impact.